Hello and welcome back to the channel where we are building a video game from scratch using Love2d and Lua. We're doing, oh hey, that's good, Squinch. If you can be the kind of king of your domain in that way. So we've got the bat chasing us. It has an attack state where it'll stop pursuing us and then attack after 1 second, and it'll pursue us wherever we're at. And then the good news is yesterday we figured out that if we open a treasure chest, we can pause the bat now, which was an issue for a while. So we fixed that, but at the expense of, if you look at the bat, see how he's moving in a completely diagonal path, and it comes generically towards us. But as soon as he gets like orthogonally close to us, he'll switch to just up or whatever. So like if we're just orthogonal to him, see how he moves just very boring, just left, or just diagonal or just down, you know? So it's like, it's not very entertaining or fun. So we did try to do this thing yesterday with this displacement value, where we modify our position by this displacement value, and that makes him kind of like backtrack every once in a while. Well, maybe that was way too much. Displacement X, let's try to put a little value in here. So we might be doing, I mean, we've got to figure out the bats, right? Oh, why? We got to figure this out. So we do have this like displacement value, which, oh, we're not scaling it by delta time, which makes it a big number. Probably. Yeah, let's scale our displacement by delta time. Okay, maybe that'll be better. I'm going to see if, Squinge, I'm going to see if we can get back that weird hiccup behavior I called it or whatever. Doesn't seem to be. I think 1 might be too little, because now that we're multiplying it by delta time, that's like 1/60th of what it used to be, so 10 is still not a huge number, but we're dividing it by 60 effectively, so let's see if we got the hiccup going. Yeah. See how he... Oh, but then he's not coming towards us. Yeah, positive 10. Oh, we've stopped. Okay. We've stopped modifying this. Okay. So, since it's just a constant value we're displacing it by, he just keeps on scrolling off. So, the idea was we deleted it, but we had this displace increase Boolean displace timer, and we used the timer to kind of increase this displacement till it hit a threshold and modify it back. Let's see what that looks like again, and see if we just absolutely hate it. So it's displace increase displacement, and we'll do it here in the update, and we'll say, you know, if our displacement increases, it's on the entity. Displace increase is true. Then we want to check the timer. Well, I guess we would take our entity's displace timer and assign it, would increment it by delta time. Then if the timer is greater than whatever threshold we want, let's say every 3 seconds. Hey, what's up, Loki? How's it going? Yeah, if the timer's greater than 3, we're going to replace or reset our timer. I have no confidence that, I mean, this isn't going to work. This is what we did yesterday, and it wasn't working, so I just want to see if we can figure something else out. So If we're increasing, which we start to be, we're going to see if our timer's past 3. We're going to reset it if so. And then swap down to decrease. So entity display increase gets false here. And then if we're increasing, we're gonna update our entity's position x by whatever the displacement value is. But we have to. Yeah, this is weird. I'm going to scale this by delta time. So we have to set our position equal to this. So entity x is equal to that. And then this would be if it's decreasing. And if it's decreasing, then if we hit the timer on the decrease, we'd swap back to increase. And then we would displace our y instead. Well, actually, yeah, I mean, I'm going to do something not consistent, and we're just going to see what this might look like if we only modify our x position on the increase and only the y on the decrease. It'll look really weird, I think. Well, he just Oh, it's because we have to do the corresponding decrement, don't we? This is so nasty. But like I'm playing around, right? Like I want to see what doing something weird would do. And we're going to do it after 1 second so he doesn't. Like I called it the hiccup yesterday, where he looks like he's like backtracking and attacking us. So Loki, I mean, it's going. See, look at how weird that is. Oh, it's so bad. Yeah, we're never decreasing it. So, okay. If we try to positively modify it here and negatively modify it here, we would still, I think we still update our position here in the process AI. We still modify our position by our walk speed, but only after we modify it by the displacement. So it's going to look, yeah, this isn't what we had last time, but that's the kind of backtracking I was thinking of. So what do we do? I don't like any of this stuff we're doing. Because like my thought process was we need a consistent distance to modify something by. So we're not changing the displacement x or y. That's stable. But we change it whether or not we're adding it or subtracting it over time. So if we're adding it after 1 second, it would only move us. Yeah, it would be too much. I think it's just too big of a value. Let's try to do 4 or something and see. Just because yesterday I had something I did like in mid-range or in close range, but it didn't look good far range, so I ended up deleting all of it. But I'm kind of curious if we can get the close range behavior back. So if we're increasing, which we are for 1 second, we're just going to shift our x position by itself. And we might have to do this after we move. After we move, well, I guess in our update, we don't process our AI here. Okay, so maybe not. I really don't know what I'm doing. we're just gonna increase our X position. Now, and this depends on what side we're on. So like, you know, if the bat is moving left and we're adding to our X position, it's gonna counteract the distance it's moving. So I feel like we might trigger it based on the orthogonals or based on the type of direction it is in the relationship, but we got to do something different. Let's see. So if we take this out and we just update our position. Oh, no. I think we're already doing this in the entity class, not in the entity state here. So yeah, so we're tracking us. Oh, look how slow he is though. The top left is very slow. I want to get rid of this stuff. I don't like this displacement stuff we're doing. Okay. Yeah, let's take that out. This should be the neutral, boring tracking. So diagonal movement, orthogonal movement, diagonal, orthogonal. Okay. So I know Stilkin yesterday was talking about doing a sine function to add the waving, like the zigzagging, which I liked and I don't know how to implement. But we've got Chat God on our side. I'm just going to take a look and see if we can understand this, right? So I asked Chat how to do like a zigzag movement to oscillate. So it's saying like introduce the oscillation with a sine wave and then combine oscillation with forward movement to offset the regular movement. And then tweak the sine's frequency and amplitude to control the speed and width of the zigzag. Because it could be cool to tweak the amplitude and or the speed, right? So like every bat might get a random amplitude or a random speed, and then all the bats will feel different than one another. So that could be cool. So what this is saying is like we're going to snag a frequency and an amplitude. So like a hertz and an amplitude. Ooh, I already don't know what we're doing here. Time gets time plus the frequency scaled by delta time. Okay, but where do we use the time? We use the time for the sine function to be the offset. Okay. What is chaser? Okay, so bat is chaser. Okay, so we already have the basic what is this, man? Normalized direction vector. If we have a distance, then we're gonna divide the dx by the distance. And distance is the square root of the square of dx times what? So I mean, I guess this is the vectors that Stilkin was talking about yesterday. Because this, you know, we aren't doing our chase logic like this at all. This vector would be way more efficient than the 8 block of orthogonal or diagonal movement that we're currently asking for. So dx, you know, we get the difference of the x positions. That's the change in x. Distance of the y, difference of the y positions, that's our dy. Then we can calculate the distance by adding our differences squared together, why would we square root once we square both of them and add them together? Is that just how you get the distance between 2 points? Then normalize the direction vector by dividing the dx by the distance. What the fuck? Then we have an offset, and we assign a sine wave function times the amplitude. And where do we use this offset? Where do we use just the offset? I'm not seeing where we even use that. Because we have an offset x and y, and we use that here, offset x and y, but I don't see where we use the offset. Oh, right here. This is way different than how we're doing it. I mean, we can give it a shot. This formula here, I have no idea about. This distance formula is the square root of dx and dy squared summed. Okay, so let's just do some quick math here, and let's just see what that might look like. So let me get GIMP open real quick. Let's put this over here. Okay, so if we imagine our player's X, or our player's position, and our bat's position, and let's just say that we're 5 pixels away on the X and 5 pixels away on the Y. So what we're doing here is saying, well, the dx is this difference. So the dx would be 5 and the dy would be 5 at this point. So dx is 5, dy is 5. That's just the difference. Then we're going to calculate the distance, which is 25 plus 25. Well, we know that's 50. But we take the square root of it. So the square root of 50. Let's see here. I've never used this type of formula. Come on, man. Okay, so the square root of 50 is like 7.07. Okay, so this is literally just Pythagorean theorem, okay, to get the distance. So yeah, the hypotenuse leg is going to be this 7. Okay, so that's all that is a squared plus b squared equals c squared. Then we do this where we normalize the direction vector. So we're going to set our dx, and this is kind of weird. We're going to say the dx is going to be set equal to our current dx divided by the distance. So what does that give us? It says it's normalized direction vector. So I guess that comes out to 0.7 on a dx. What up, Squinch? Yeah, Sasquatch. I just realized it. But it's like I've never done this stuff before. The vectors and stuff. So the dx divided by the distance gives us 0.7 for a normalized direction vector. And same with dy. So it's like this would be, oh, I guess since we're doing the difference here, player is a smaller value minus chaser, which is a bigger value, so this would be a negative dx. So this dx normalized would be a negative 0.7, and then the dy would be the player's y, subtract a bigger number, so this would also be negative. So after we normalize the vector, we'd have a negative 0.7 for both dx and dy, meaning that the bat needs to go up and to the left to get to the player, to meet the chaser. And it's going up by 0.7. See, and is that per frame? It's going up by 0.7 and left by 0.7. And we just did a 5x5. Yeah, maybe we should have done two different values just to see what the change in dy would be. Normalized vector clamps it to the unit circle. Okay, so that's useful for when we do the sine function. Okay. Because we take, well, I guess, so it's like once we get this normalized vector, it's just a better dx for us to multiply by the offset. So if we then take an offset and we give it this ever-growing zigzag time with multiple, we can scale it with the frequency, so we can have a bigger or a faster frequency and a more amplitudinous frequency. That becomes our offset. And then if we look at the grand scheme of things, all we do is we add this offset and we add this offset and we update our position by current position plus the speed times delta time times delta x. Then we add the offset. Now, what does it mean by perpendicular to the movement? Oh yeah, because it's like we only want to zigzag. If we're going left, we want to zigzag up and down. If we're going up, we want to zigzag left and right. So we're saying we're setting the offset to be, we're going to offset our x only by our y-ward velocity. So if we're going up, that's when we offset our x. And then if we're going left and right, that's when we offset our y. Okay, so I think all that makes sense to me. The only thing that we're screwed up at is like we have a bat walk speed, I think it's called, which is going to be this speed. And we've got a code block of at least 8 different scenarios for our orthogonals and diagonals. So we're going to have to gut all of that in order to try this, but I think this could be the move. And this is just, the vectors are just cooler to work with. I've never done that, so we should probably get some experience doing that. And I don't like to just run the code without knowing what it's doing. So I'm glad I, kind of just took the time to dissect it, and then we can see what works and what we want to do. So right here, see all this junk? Look at what we're currently doing. I mean, it looks a little similar, right, with the square root. Let's see. Yeah, we have this distance to player, which we're calculating with... Look at how crazy. We did all of this junk. You're shitting me. Look at our get distance to player function. We literally have this many lines, and ChatGPT gives us one line, and it just does it. I mean 3 lines, because it calculates the dx dy. Okay, well. Okay. So, let us take out our old logic, and we will see what we want to keep. So let's just get rid of the if distance to player is greater than 10, we're going to modify by our walk speed. We do need to change to bat attack if our distance is less than 10. So we should probably still keep that, because we do need to handle the state machine, right? So we can turn... What we can do is we can just have a function that takes in a player and a bat, and it spits out the distance between the two. If that distance is smaller than whatever threshold we want, which is 10 at the moment, then we're gonna... Oh, see? And you know what? This might be a little... This might be screwed up, because depending on where the bat... Let's just test it, because we had a bunch of that junk, because we need the distance between whatever the... How do I even word that? Like, distance between the closest 2 points. And depending on the orientation of the 2 squares, the distance between the 2 points are at different corners of the different entities. So I wonder if this vector solution calculates any of that. It looks like it's just based off the x and y position, so I would think it wouldn't. So let's just try to do the distance function. So like we've got a function now. It says get distance to player. Let's just write a new one called get distance, and it'll be a lot simpler. It'll take in a player and an entity, and all it does is we will store the change in x position the change in y position, and then we should probably return this distance, right? So we can just return the square root of our dx squared plus dy squared. Okay, so now our get distance function, if we do it, we need to assign the return value as the distance. And then we can do this where we're saying, like, if our distance is greater than 0, let's normalize the vector here to be within 1, clamp it to 1 for our sine function. But then if our distance is greater than or less than 10, yeah, if it's greater than 0, we want to do this only if it's not less than 10. If it's less than 10, we need to change to the attack state. So we can say local distance gets our getDistance function. And we're going to pass in the player as well as our own bat from this walk state. Okay, so we've got the distance. We're going to say if the distance is smaller than 10, then we're going to change our state to attack, which will stop updating our Y and X and start the timer for a spitball. Then we're going to say else if our distance is just positive, then we're going to normalize our vector. So we're going to say, oh, and you know what? Yeah, we kind of do have to, we need to pull this variable out, this dx variable, so we can't really do the function here. I don't want globals there, so we'll do that. We'll say, let's, you know, we'll snag this. We'll snag our dx, dy, and we'll snag our distance. And then we'll do that change, and then if the distance is bigger than 0, we're going to normalize our vector of our dx by dividing by distance. Same with dy. Okay. Now we need to calculate this offset. So we need I kind of like how they did it up here with we take in we create a zigzag object, and it has the variables for the time initialization, the frequency of the oscillation, and the amplitude of the zigzag. Okay. So we have a whole table with those things. Now we could, you know, this could be the required potential parameters for the bat so that we can give them different frequencies. So for right now, we're just going to say this zigzag is a 5 and a 50 amplitude. 50s can be way too much. So like, I think we're, I don't know. Let's try to put 20 and see how crazy that is. So we have this zigzag variable, and what we're going to do is calculate an offset for us by taking the time, which is going to be, now don't we have to, yes, we have to change our time so that our sine function gives us a different value over time. So when we process our AI, we're gonna take our zigzag time and we're gonna scale it by the frequency. So we're gonna say zigzag time gets itself plus the frequency scaled by the delta time. So we can say plus zigzag frequency, which is 5, scaled by the delta time. So that'll give us an ever-growing time value to calculate in our sine function. And it's scaled by frequency, so the output of that will be different if we change the frequency. So then we have an offset value, and we use that ever-growing time variable. But then we also scale that by the amplitude to get a bigger offset based on the amplitude. So we have this offset scaled in a sine function, so it should oscillate, and it's scaled by the amplitude. Then we're gonna only apply an x offset when we have a y-word velocity. So we're going to multiply our offset by the change in y, and we're going to offset our y by the change in x. Now, we have a negative dy. I don't get why we're doing a negative dy times the offset if we have negative dy. Why do we multiply our change in y by negative here? I guess so. If we didn't, it would be, I don't know. Let's test it. If we get it working, we can switch it and see how it affects. So we have our offset there. Now we have to update our bat's position based on this offset. So we have this offset calculated. So let us go and set our entity's x position to be equal to its current x position plus, and then we need to modify the walk speed here. Well, we say the x gets modified by the dx, the normalized dx, and we say multiplied by our bat's walk speed we scale it by delta time, and then we add our x offset. Then our y is updated by our dy, scaled by the walk speed multiplied by delta time, plus our offset y. So all we do is just update our x and y position by this offset that we calculated with our zigzag, and we'll see how jacked up it is. Okay, so global entity is a nil value at 108. It's not entity, it is self.entity. We need a lesser amplitude. For sure. Let's put in a 1. Let's put in a 1 and see. Okay. Now it is not, it's not getting closer to us. It's just oscillating. It looks pretty cool. Whoa. Looks pretty cool though. Now, it's also not changing into attack state, but look, it does change oscillating depending on what... well, no, it is moving. Maybe our walk speed is just so slow? Okay. Let's when we go to input our bat, let's just put it a little closer to the center, and we'll keep tweaking with this, because this doesn't add the pursuing, it's just adding the oscillation. So we might need something like we used to have, which was like, get closer to us depending on the distance. But when we go and add our bat, let's just spawn him a little closer, right? So we're putting a bat here. We'll give it a random x of only 30. Just want him a little closer to the center. Okay, so he's in idle state, and then he's in walk state, which is just this oscillation. So look, he does this, he's oscillating left and right when we're beneath him, and when we're on the side of him, he oscillates up and down. So that's really cool. And then depending on, wow, that's really freaky. You know, he's not getting he's not pursuing us, but he is offsetting. It does look really sweet. I do like this. Oh wait, but we are not turning into the attack state. If once he gets close enough, so we need to add the pursuing. The oscillation looks pretty good. You know, I kind of like. You know, ideally we'd probably want the frequency to be higher and the amplitude to be lower. So let's double our frequency and half our amplitude. See, I don't like how amplitude's already 1. You know, ideally we would give it like a 1 through 10, and those are all decent values. Nice. Yeah. Frequency could be... He's still a bit too fast, so maybe just a little bit higher, and we'll give it just a little higher of a amplitude. Nice. This is sweet, because this will help prevent them from overlapping with one another, because we can give them slightly different amplitudes and frequencies. So that's pretty sweet. It would be kind of cool. Well, that's pretty sweet. I don't know. I kind of like him moving like that. I don't like... Now I'm thinking that we don't... Like, we still need him to pursue us, but I don't think we need him to stop moving once he gets a certain distance, because then he can just spit at us, and we can still hit him. Okay, this is pretty sweet. So I think if we add the pursuing and make our attack state keep our... Let me think, because we had a attack state because our attack logic was different than our pursue logic. But now, if I like him still waving with our sine zigzag, then maybe our attack doesn't become its own state, and instead it's just part of the bat pursue, and if he's in range, he'll start attacking. If he's out of range, he won't attack. And then we can... I guess the only thing is like, it's hard when he's zigzagging, it's hard to tell if he's in range to attack us, because he's constantly changing directions. But the good thing is, since we only add the perpendicular zigzag, if he's in range perpendicularly to us, then he's oscillating about within the range of our spellcast, which is a circle. So if he's he'll be oscillating in the range of our spellcast. So this should work. So we're not... Let's take a look at our bat attack state and see all we're doing. We're basically saying we're going to set a timer if we're in range, right? Because the attack state right now is once we become in range, we don't update our position and we just start counting. And if we pass the counting threshold, we instantiate a spitball in our attacks table from our bat. So that's literally all we do in attack state, is just insert a spitball if we're past the timer threshold. So what we can do is move this timer into, we have an attack timer on the bat. If we're in the range, of 10 pixels distance away from our player, we can increment this timer. Anytime we're greater than 10, we reset it to 0. then all we do is instantiate a spitball after the timer's passed a second. And everything else should be the same. So let's, we do, and the thing is we're already changing the state to bat flee in the walk state because we just did it. So yeah, this would simplify the bat logic. So I think what we might need, I'm just going to paste this here for now. What we do need is our original get distance from player, because that takes into account what side we are compared to the bat, and it takes into account the bat's height and width so that we get a more accurate distance to the player. So we do need this still. So what we can do is in our process AI, or I guess it would be in the process AI, not the update, right? We can run our get distance to player, and let's just say that local distance to player is the result of get distance to player. Now this would be self dot entity. So does our player, what does this function get distance to player is calculating the distance from the player and then assigning it into the entity's dot distance to player field. Okay, so all we're doing is, it'll change the entity's distance to player. So we don't need a local distance to player. All we need to do is run the function, and the self.entity's dot distance to player field gets updated with the result. So let's just try where we can say if the self.distance to player, self.entity distance to player is smaller than 10, then let's just try to attack for right now and just see if that's looking accurate. Okay. So all we're doing is we're going into the current map and row of our attack table, and we're inserting a spitball with the given bat. So let's see. So it's gonna oscillate, and then as soon as we're within 10 pixels, hopefully it'll spit at us. Oh my, that freaked me out. Okay, 10, yeah, holy crap. He does so much damage. Holy shit. He killed me a while back. Wow. Okay. You know what? I kind of like the spitballs. It looks pretty awesome. Okay. I'm kind of liking that. But see what I'm saying? Like, if he's oscillating, our spell would still be able to hit him even though he's changing his X and Y. Mainly the perpendicular one. So now instead of doing this, if we're in this range, we just need to increment that counter, that attack timer for the entity. And we could do, I like the stream of spit. I think it looks cool, but it does so much damage. I mean, we can change it. I don't know. The spit, it's like string shot. It's like a caterpillar string shot. I kind of like it. Yeah, I don't know. I kind of like it. Maybe... Yeah, I mean, we can make the spitballs do 0.33 damage each and just fire 3 at once. Or 3, in succession. Or, I don't know. let's just do one at a time. So let's go to our let's go to our entity and make sure it has, our bat entity would need a dot timer, attack timer, and we can add that to the walk state. Well, I don't know, maybe we do add it to our entity itself. So what we can do is once we get in a bat's walk state, we can say, let's just initialize an attack timer to be 0. And then once we get our distance, instead of just adding the spitball right away, we're going to increment our attack timer. And if we're out of distance, we need to reset our attack timer. So entity attack timer will get reset to 0 here. And we will take our attack timer and increment it here. So we'll say attack timer gets modified by delta time. Okay. And then we only insert a spitball if our self.entity attack timer is greater than a second. So if we're in range for more than a second, go ahead and spit at us. So what I am a little worried about is, like, let's say the bat's barely in range of us. You know, he's about 10 away from us, right? If he's about 10 away from us, but when he oscillates, he goes from like 9 to 10.1 and then back down to 9 and 10.1, and that's, since his frequency is a certain speed, he might be resetting his attack timer every time he is 10.1 above us, and then he never ends up spitting, even though most of the time he's sitting there at a 9.4 range and doesn't spit at us. So I guess that would be something we would change in the pursue logic. We would just make sure he comes a little bit closer so that he can spit at us. So he's not quite within 10 from us here. I'm not... Oh! That freaked me out again. So he does spit if we get in range, but it's a little too close. Yeah, holy crap, he just... Okay, so I think we can afford to make this distance a little bit bigger to give us some wiggle room for the oscillation. And then also, we need to reset our timer to 0 if we've passed that timer threshold so we don't accidentally spit 50 bullets at us. So let's try this. Wait, if the distance to player is shorter than 15... Yeah, that should give us a bigger range to get closer, so he'll spit at us sooner. So if we're a little closer to him. So he's oscillating. Does he spit at us here? Yeah, he does. Nice. $15 looks about the good distance, because if we can reach him with our spell casting, then he should be able to spit at us. So this is about the range. And maybe there's like... see, and then this is tough, because when we add him pursuing us, I guess we would add the distance before we calculate this offset. So like he would get, you know, offset aside, which if we look and we just don't do the offset, which is right here, if we just don't do the offset, we should just, I mean, we're not even scaling by our walk speed at this point. Okay, so there's no offset. So without the offset, he just sits there. So like if we calculate the distance to come close to us based on the distance before the offset, that gives us a sort of like original position. Because as he's moving, we don't want him inching closer to us, because as he oscillates out of range for us, we don't want him sneaking up closer as he gets out of range, because that would probably look weird. So we should calculate the distance to stop coming closer to us before we apply this offset, which makes sense. But we're not scaling the like, we're saying that our dy gets multiplied by our walk speed. Oh, yeah. And then we're, okay, so maybe what we need to do is, I think our walk speed needs to be out. Let me just see if we can put our walk speed out of this, so we can scale our y position by our walk speed and then add the delta y. I don't know if that's right. Let's see. I just want him to, yeah, okay. Okay, so I guess if we want our amplitude to be less tiny when we pass it in as an argument, we can just scale this walk speed a bit, because we're just changing how this is working completely now. Okay, so let's see what our walk speed is and see if we can scale it to get our amplitude a little easier to work with. Yeah, walk speed is 15. Let's say walk speed is not 0.15, but positive 15. Now our amplitude should be crazy high, right? Okay. Okay. Yeah, okay, so he's only in pursue state, but this is really cool. That's looking great. Oh my, yeah, it's freaky. It's freaky. I don't like him. He's freaky. That's awesome. Wow, I think that's it. That looks so good, because our walk speed was so tiny, we weren't actually making much progress towards him flying towards us. So when we scaled up our walk speed, it kind of just solved everything for us. Okay, now we're triggering this attack state, which we need to turn off from our walk state for the bat. So let's say anytime we have this attack state, we just need to not change the state. So if the distance, yeah, see, we don't have this anymore. So let's just do, if our distance is greater than 0, we're going to normalize that distance. This is looking really good. Wow. Yes, so what we do need to do is we need to stop scaling his X position based on his walk speed if his distance to the player is less than 10 or 15 or whatever we decide. Because he shouldn't be, this is too hectic, because once we put the floor in the dungeon, he it's basically, he's just way too aggressive. It's way too aggressive. And making him slower would help a bit, but we need to give the player a shot to kill him before, because if we just stand here, he just murders us. He just shot us out of the freaking dungeon. That looks really good, though. Yeah. That looks really good. Wow. Yeah, Stilken was on it. Vectors are the way to go. And when we open a chest, he doesn't update, which was like the whole reason we had to fix this. But this is a way better method anyway. So the big thing now is just to say, you know, we need to basically say if our distance to player is less than 15, then we can assign our walk speed to be nothing, so we don't scale our original position before the offset. But if our distance is greater than 15, we can give us the original defined walk speed, which we can snag in the entity, but or in this state, but I don't remember what it is. Just 15. Okay. Okay, so let's see if we stop pursuing. You know, I don't want him to fly to us and hit us. He needs to fly within range and then spit at us. Perfect. Oh, look at that. Perfect. Oh, see, look at here. He's not spitting. Oh, he did because his timer must have hit. See, look at this. He's... Oh. It's a little random. It's pretty damn good, though. I feel like we need to shrink the threshold. I think we can make it a little bit closer. And what we can do is we can make this a little bit closer. Distance to player is 13. But then let's add a second to our attack timer. So it's a little less forgiving on the distance, but it's a little more forgiving in terms of frequency of spits. The other thing is, if we're incrementing our attack timer, whenever we're close enough, we also need to... Oh, we do flush our attack timer when we're out of range. Okay, so let's try this. Let's try this closer distance, but longer time to spit. Let's see. He's not spitting. Let us print what the distance to player is here. Okay, let's see if that 13 is a good threshold. Yeah, see, he's oscillating and he must be passing 13. But let's see what above him 13 still might be, well, yeah, 13 would be good there. 13 should be good there. So what this is telling me is like our top, or, oh man. Yeah, let's try 12. And if that doesn't fix it, then we have to change our distance to player to be a little more accurate, because ideally we should have the same distance to player on any side so that he's about... Yeah. And then 2 seconds. Wow, he's not spitting. He's really not spitting. Yeah, maybe this is like... Oh, smaller than 10. Okay, so we need this to be a little bit... Yeah, we need a bigger number than 15. So let's put 16 and with the more time, it should be pretty good. Okay, well, this just determines if our player is smaller than 16, then we're going to do our timer. We need to modify Yeah, because even if we give a bigger number like this doesn't help us. Oh, we need to modify our distance to player to be a little more accurate. Because if we do this, then he'll stop when he's very far away. Yeah, see? And we need him to stop. We just need the distance to player to be a little more accurate. So let's take a look. If we clamp it at 15, it's not really clamped because he oscillates within that distance. So when he's oscillating like that, it's 14, right? So like he'll oscillate within that 15 range, but when we're above him, yeah, he oscillates. Well, why does he get closer there? Yeah, see, he needs to be a bit closer when he's above us. Left looks okay. Bottom, he could be a little bit closer. Right looks okay. Up looks okay. So when he's above us, it looks okay. When he's on the right of us, he looks okay. So we just need to tweak when he's below us. We can get, well, no, but below looks fine. So I think it's mainly just top. So when he's above us, we need to allow him to get a little bit closer. So we need to modify when the bat is above us. So bat is on top of player. Top left of bat to bottom right. Okay. Bat. Here we go. What the? Okay. So this is bottom of bat. Okay. Okay, so we're... Gosh. If our bat's above us, then our distance to player becomes the top of our player subtracted by the entity height, and then we need what, a smaller value? Let me just try to -5 here when he's above us and see if he gets a little closer. So when he's above us, he should get a little closer than he's been getting. Nice. That looks more correct, but a little off. Let's do a -3. I don't like the magic number there, but it's just so strange with the oscillation and the difference in width and height from our bat to our player. It looks decent like that. Like that looks pretty accurate. That looks pretty accurate. Now, we know it's good because we can hit him with the spellcast. So we know that's a good distance for him to hover at. Then we just need to make sure we're doing the timer increments. So we know top and right is good. Left, we can hit him. And if he's above us, we can hit him too. Cool. So that looks okay. For this, we just if we were to print up the attack timer, we'll see any of the states where he is going out of range. So let's go to our walk state, and instead of printing up the distance to the player, we want to print up the attack timer. And we want to see this, he attacks when the attack timer's 2. So we need to see when it's getting reset. So if he's on the right of us, let's see if it gets reset. See how it's not quite reaching 2, so he never spits. But we could, it does reach 1.7, so we can just lower the threshold for the timing there. But yeah, it gets just above 1, and then he happened to hit us there. Ooh, he gets really close on the left side, but doesn't do it. He hits us when he's above us. So we might, I think we just need to shrink the distance to player so he's a little bit closer to us before he stops. So when he's on the right of us, we need to have him get a little bit closer so that timer doesn't reset. So when he's on the right side of us, and this is a little different too, because like once we change the amplitude, I mean, we should have a max amplitude, and we can just give it a random value in between a certain amplitude so we know he doesn't get set past where he would reset his spit timer, so he never actually spits at you. But when he's on the right of us, let's see if it's when he's in the right up or below. So like we'll do when he's right up, top right of us. Top right, yeah, he really doesn't hit 2 seconds. So top right, he needs to be closer, and bottom right, he actually hits us. Not all the time. Okay. So it looks like both bottom right and top right can be a little closer. So what did we do here? Do we shrink? What we did before to get him closer was we just shrunk the distance to player by about 3. But here, we're not calculating the distance to player until we calculate the C length. So the A length would need to be smaller and the B length. So let's just try the minus 3 in here for both of these directions, and we'll see. We'll see if the timer doesn't reset. See, he should get a little bit closer to us. Not quite. Because he's resetting before he even gets to 1 second. So I'm wondering if we can shift this even more. We might. Let's see. Yeah, it's still only hitting like 1. The oscillation's too much, you know? We can change its amplitude a bit, but I like how it looks, so I don't want to change it that much. Okay, I think we would. I mean, yeah, we just need to shrink. If we shrink both, I don't know. Because maybe the distance to player doesn't. The distance to player shouldn't calculate the offset is the thing. So it shouldn't take what the player's X is. Oh shit. We have to calculate it with the offset because its real position is taking into account the offset. So bat is on the right, bat is in the top right. Okay, so why doesn't this work? Why can't we just... Let's just say if we put -10 in here just to see what it looks like when the bat is in. Oh, this is in bat in the top right. We want bottom left. Let's try the -5 here and see if it lets us get a little bit closer. Because we're looking for him to hit that 2-second threshold when he's in the bottom right of us. Still no. Bottom right, bottom left. what else we can do is, instead of doing this, we can just not flush. What we can do, we can be a little more lenient on the distance. Well, let me see. When we go to do the attack timer incrementation, so we can say, well, if our distance, if we're greater than this 13-ish distance, we're going to increment the attack timer, but then let's not reset the attack timer once we're out of distance. So if the bat was close enough to you for 1.9 seconds and then he got away from you, the next time he's within 0.10 seconds of range of you, he'll shoot, and then that'll make it so that he doesn't ever not spit at you by hovering there. I don't know if I like that fix though, because look, he still has that on his timer, and then he gets to 2 seconds and then he finally hits you. You know what? That does kind of feel okay. Because, like, he kind of earned that much, you know? He was very close to getting you, and you got away, but then as soon as he's in range, he's like, boom, gotcha. And then the 2 seconds is more lenient on the timing for there. So I do think that's good. I mean, we can probably slow down his walk speed because he is still very aggressive. So let's slow down his walk speed and see if 2 seconds still feels okay. And we would need to pull the original walk speed so that we don't have the magic number in here. So let's reset by his original walk speed. So what we'll do is we'll say that your walk speed gets reset to the original walk speed we pulled for you. And then we'll just snag the original walk speed once we're in this state. So we'll assign right off the bat the walk speed based off the original walk speed, which I guess... No. All we have to do is say original walk speed gets whatever we instantiate it as. So we can say entity walk speed. And then it'll get reset to its original... Let me think that through. Yeah, because it gets initted right here, right off the bat, and then this original walk speed never gets updated after that. So that should work. I don't like that magic 3 in there, but that was pretty necessary to kind of adjust the distance. Okay, so let's first of all take off this render for the attack timer. So we'll take that out, and then we'll slow down our walk speed just a bit. Yeah, let's see what 11 looks like. And then this way too, you know, if you're circling him and being like, nah, he'll still get you because you're in range of him for longer than a second. So I like that aspect of it too. That's pretty good. Oh, I think I just saw us get a weird... No? This is looking pretty good. Okay, so I guess what we can do... Displacement magnitude, we're not doing that. We're not doing that, and we don't have an AI path either for our bat. Okay, this walk speed is pretty good. Because if he's chasing us, he does a lot of zigzag, but he also does, you know, it gives you time to kind of maneuver away from him. Yeah, he's also very scary. So if he's in range to hit us, we're in range to hit him. So that's the kind of idea behind that guy. Now, let's give us other bats and see if they overlap and get stuck. If we block its oscillation, we'll collide with it and he'll knock us back whatever direction he hits us. I can show you what that looks like, but let's give a walk speed here of maybe 12. And we can also define our frequency and stuff here. If we define it in the entity right here, let's try that. So we'll give ourselves 3 bats, and then let's just see where they spawn if it's all crazy. Not bat C, but bat. Nice. So see how they have this. Oh god, they have the same frequency, which looks weird. They're all dancing together. Oh my god. See, but look, they are overlapping here. See how they get kind of synced with one another? So that's what we want to avoid by modifying their walk speed a bit, modifying their frequency a bit, modifying their amplitude a bit. And then look, I'll see what happens if we block their oscillation for you, Squinch, and they're like, oh, is that, oh, what the, well, that guy's not tracking us. That one's not tracking us. Maybe because we didn't give him a walk speed that was appropriate. Okay. We don't have the AI path either. Okay. So they should all track us, but they're synced. Oh, that looks so weird. Okay, so let's do this where in our bat walk state, instead of our zigzag being defined right here locally, where is our zigzag? Right here. Okay, we will make, let's make a self entity dot zigzag. And it'll be like this one, where it's just a table of these values. And then we would get, we can say, I guess we can just define this in the, yeah, what we can do is we can define this when we instantiate them. So let's see, declarations, and we can say there's a zigzag table with multiple values in there. And then in our, over here, instead of doing zigzag, it'd be self. Let's do this. We can say find any zigzag replaced with self.entity dot zigzag. Okay, so now it's being modified by the assignment we do on the, oh, we need this too, zigzag amplitude. Okay, as long as we don't have any other naked zigzag in there, we should be okay. And then we need to make sure in our declarations, we give this zigzag to each of our bats. So let's go a little crazy with it just to prove a point and test, right? So like, let's say the frequency of one of them is like 14, same amplitude. And then I guess we'll make the first, like, it doesn't matter. Let's make this frequency like 25, so it should be crazy fast. So one of them should be crazy fast, and one of them will be crazy amplitude, big distance. And we'll see if they get those different values. Hey Mochu, what's up? How's it going? Hey, zigzag, a nil value at 108. We must have forgot a naked zigzag. Zigzag time, zigzag frequency, self.entity.zigzag.time. It might have to be like this. Because it's a table of keys? I don't know. Because we assign it as a table, so we're saying get us the value at the key of frequency that we put in there. And then also here, not the dot time, because there's 3 things in there, and we need the value at the key of time and the value at the key of amplitude. Okay, let's hope this works. We should get some crazy shit. No! 108 still doesn't like that. Self-entity zigzag. Self-entity zigzag. It doesn't like 108. Okay, so when we define it like this, could we do it like this where we say, oh, I think I know what we have to do. We might have to, in our entity class, we might have to assign this based on the definitions. So if we go to the entity class, we'll see that we're assigning this based on the defs here. So we can say self.zigzag time gets the defined zigzag at key time. Would that be appropriate? And then we need frequency and amplitude. And then we can use the dot. Well, actually we could do, I like keeping the zigzag just because it's a little more verbose. And then we can do not the key anymore because we change it into the field. I don't know if this will work. There's 108, so let's see. If we don't crash on 108, we might be okay. No. Entity 25 zigzag and nil value. Okay, so it doesn't like that we pass in this. So maybe what we can do is say just .zigzag is gonna be the whole table we define. And then the frequency would be the zigzag at the key. I don't know. Because we snag, we would still need time. Okay, so we're saying go snag the whole table from our defined to .zigzag. Let's make sure we're doing that. we say dot zigzag is one table, and it's a table with a bunch of different values. Then we're saying assign into that dot zigzag dot time field the whole table, but the value that's at the index of time. Okay, that might work. No. Zigzag a nil value. Dot zigzag dot zigzag. Okay, so we could just say, okay. Well, how do we do this? Dot zigzag def zigzag for entity. There's we need to do this or nil because only our bats have a zigzag, so our any other entity, well, no, still doesn't work. Zigzag. Zigzag is a table. Okay. Let's try this where we say zigzag time. We'll just do it individually instead of a table like that. I should figure out how to do that though. Frequency. Okay, so we have a zigzag frequency, zigzag time, zigzag amplitude. So we're gonna say we only have, okay. Well, we pull from our defined zigzag time. And we can say, just keep the same convention there. Okay. Okay. Okay, so we just pulled the individual fields one by one, and then when we go in our line 108 of our, not our entity, but in our walk state, bat walk state, we do zigzag time, zigzag time, zigzag frequency. Let's see if we crash at 108. No, we don't. We crash elsewhere, which is because we do this other zigzag right here. So this will be time. This will be amplitude. Okay. This should be it. Okay, we should see some crazy behavior here. Son of a 108. You don't like frequency, a nil value. Oh, our other bats aren't given the same values here. So we need to. We can take this, and we can make sure our other bat. Oh, we only gave it to our last bat. So yeah, first bat is going to have the normal, whatever, 0.06 amplitude. 0.6 amplitude, and then we're gonna have one with a crazy frequency, and then we're gonna have one with a crazy amplitude. So this one's gonna have a 20 amplitude. Okay, so now finally it should be crazy. Oh my god. What happened, man? Okay. Yeah, the which one went crazy? The amplitude? Amplitude guy went crazy. But we're getting the individual, we're modifying their frequencies and amplitudes Wow. Okay. What one is... That's got to be the... Is that the frequency one? Yeah, frequency one is nuts. Wow. Okay. Yeah, he's crazy. Okay, so maybe we don't mess with the frequency all that much. You know, we need to find like a range that we like of... Wow, see, yes, look at that. See how they're not synced anymore? That's great. Well, that guy's a crazy. That's got to be amplitude one. Okay. So amplitude one can maybe get point. Let's do a math random. Math.random. In between two values, we'll do a 0.3 to a 0.7. And that'll be the amplitude for all of them. And then we'll do the same with the frequency, and we'll just play around with what is a good random setting for them. Okay, so amplitude's probably we probably want 0.4 to 0.6. Let's see how that looks. What do we do? What do we do? Commas. Okay, let's see. We screwed up frequency. Okay. Come on. Time, frequency, amplitude. Time, frequency. Yeah, how do we screw this up? Time, frequency, time. Wow, we really screwed that up. Time, frequency. Okay. This should be it. Okay, son of a... Wow, that's nuts. What was the original values we did? Because... Oh, frequency was 5. So let's do in between 4 and... Let's do 5. So either 4 or 5 frequency, and then 0.3 or 0.7. And we could, if we like these hard-coded, we can just put it into the walk state init so we don't have to type it for every single entity. Yeah, that's nuts. The frequency is too much. I think we just need a... Like, if we do a range, it needs to be like between 4.5 and 5. Because there's too much variation in the frequency there, I think. But then, yeah, let's do 0.5 to 0.7 for the amplitude. You know, we don't want a lot of variation. We want them to be pretty much the same, but not exactly the same, like close. Nice. Yes, I love it. Oh, that looks great. Yes. I don't think there'll be 3 bats at once, but this is really sweet. Okay, we don't have damage flash still. How hard would it be to add the damage flash? Do we have it in the walk state for the bat? I think it's in the entity. Damage flash. I want to say it's in the entity for the render. Damage flash. Then in the render. Oh, we have a dot flashing. Okay. So when do we do dot flashing? We say if our damage flash, then we take our damage flash timer. Okay, so as long as we become damage flash, we should become flashing, which will then change our render color to red and alternate. So, oh, but only if it's, okay, so that's where it's going wrong. If our entity is of type, oh, is of not type spellcast. Okay, so if we become dot flashing on our bat entity, we should be damage flash. Let me just test that. Let's go to the walk state, and we'll say that we're just gonna turn our damage flash to true. Let's see if one of them's flashing, or all of them flashing. No, they don't. There would be issues in the sense that, like, we have collision, you know, they can only collide with us at the moment. They don't collide with each other. So what could go wrong is one of them knocks us up into another one that knocks us down into another one and kind of like does all that junk. But we do reset the position of the bats if they collide with us to be not colliding with us. So it would kind of, it could get all jumbly and nasty. So you're right. If we have no health, we want damage flash true. So in our bat state, yeah, we want, if we have less than 0 health, oh, we're gonna flee. Okay, so when do we do our spellcast to bat, or spellcast? No? Spell to bat? Spellcast to bat collision. Our damage flash is true here in the entity. So if a fire spell collides with our bat entity here, we're saying damage flash is true. Play the sound and do the knockback, become hit. So we do go to damage flash being true in this entity update, and then in our bat walk state, which we're in. Oh, and it's actually, when we go to render ourselves, we're setting the flashing based on damage flashing is false. Okay, in our entity update, if we have damage flash turned on, we decrement our flash timer, which should be a positive number. Flash timer is a flash frequency. Yes. Okay, and then we say until our flash timer is less than 0, then, or if we're damage flashing, gosh, what are we doing here? We take this flash duration and subtract it, because we're only going to flash for like a second after being hit. And you know what? Maybe we just our damage. Yeah, you know what? Maybe all we do is I think because we already have a boolean for this and it's the dot hit. You know, if we were recently hit. So we can flash for as long as we're being knocked back, and that seems about appropriate, right? The only other thing is like and Squinge, when a bat collides with the player, we actually shoot. I think we only move the player's position to be not colliding with the bat. So I don't think the bats will be teleporting around the place. I think we would, if it gets crazy. I could be wrong on that though. Okay, so yeah, I can think of a scenario like if we fall down a pit when we respawn, we're flashing, and that would mean we're not technically hit at that point. Because hit is only if our... I don't know. It doesn't really matter. But I'd like to get, we damage flash true here in our self.entity. So we know this is happening because we lose... Oh, actually. If the entity collides... Okay, yeah, then we take the entity's health down. We play the hurt sound. We give the entity a spell knockback DX. Okay. Okay, so let's just print up if we're damage flash or not and see if that's correct. Because I feel like we're setting it right, so I don't know what's wrong. Not attack state. We got to get rid of attack state. But here we can put damage flash value. So self.entity.damage flash. Because they're not blinking red, but I think this damage flash is getting set. Oh god. We need to convert the bool to a string here. Okay, so no one's damage flashing. Let's try to hit him. Yeah, damage flashing. Okay, so the damage flash boolean is getting set right, so something's going wrong. If we're in our entity class. When we go to render, we do... Oh, particle system, okay. Okay, so we're going to set the color if we're not of type spellcast, meaning if we're... Okay, so let's print up the self-flashing value, and if that's incorrect too, then I really don't know what's wrong. So let's try the flashing value. So like damage flash is like we're in the state of flashing red and white, but flashing is if we're actually flashing red or not. Okay, so this is nil. See, it does flicker. It flickers like it should. So we should... It does flicker. So damage flash and flashing seem to be working fine. It's just the render doesn't work for some reason. The set color, love.graphics set color red. That should be working. Only thing I could think of is like they're so dark purple that setting the color doesn't change anything. But we can try. We can try just setting it to be like transparent. So like if we say 1, 1, 1, that'll be white, but then we give it like a semi transparent value for the dot flashing and see if we can see through them. No, we can't. Okay. That is in the entity render. If the type does not equal spellcast, are we giving them a type? We're giving them a type of bat, not spellcast. We're so close. We're so close that I don't want to move on until we get it, because we're so close. Damage flash is correct. Flashing is correct. So maybe let's just see. If we take out that. No, they're still not flashing. Okay. It's got to be in our state machine render. We're changing the color. That has to be it. So in our bat attack, we should, in our render, we are setting color here. Why are we setting color to, what are we? Okay, not the attack state, the walk state. We got to get rid of the attack state. But we are setting the color right here. So we just need to not do that. That's why. Okay, we should have our flashing. Our damage flash. So once we hit them with a spell cast, they should flash. Nice. Yes. And then once we hit them twice, they flee and they turn brown. So it's still the programmer art bat stuff. And let's see, Squinch, let's see if they knock us around all weird. Let's see. So we'll kind of get them going and then we'll join in on the fun. It's not bad. It doesn't really teleport us all that much because we kind of, they just bully us. Oh my god, this is like tennis but for bats. This is cool. Now look at, see how they're kind of synced? I don't like that those two are kind of synced. We should vary the variables just a bit on the frequency and the, oh, we can change the walk speed too. So we could, yeah, we could give the walk speed a random value too, between like 9 and, I'll try that, Squinge. I'll try to run into him too. Let's do, instead of a walk speed of 11, let's do 9 to 12. And then we'll see. I'll probably end up, since the frequency and the amplitude are the same range and the walk speed, we might just define that in the walk state. Hey, Sabis Barthrow, thank you for the follow. I appreciate that. Hopefully you weren't in ads. Hopefully you're on that prime or turbo action. Okay, so walk speed is gonna get this value 9 to 12. And just because we give it a math.random 9 to 12, that doesn't ensure we get different values. So, you know, we could run the math.random 9 through 12 3 times and get 9 each time. So let's tweak our amplitude a little bit and our frequency a little bit. Cool. And then if we're happy with that, we'll put it into the walk state. Okay, let's see. Hey. I don't see the issue. Map declarations. Yeah. Oh, comma. Okay. That looks great. Yeah, Squinch, they can get a little screwy. When we walk into them. But look, if I try to get them synced, they like, you can still see them. They don't get as synced as easily because they have the different frequency. Oh, well, that's okay though. I can see that they're in there. It doesn't bug me that they look like, you can still see that they're there. There's not one that's ever like permanently a shadow, and it depends on what the random values are for the walk speed. So maybe we can vary the walk speed maybe a bit more, vary the frequency a bit more, and then call it good. And then yeah, we'll put all these declarations in the idle state, or in the init for the idle state, because we start off as idle, and then we only have to define those once, so that we don't have to keep changing it like this. So we can say this should go up to 6, let's say, and see if that's good. Wow, this is looking good. See, I'm trying to get them to overlap, and you can still see that there's 3 distinct ones. They do mimic each other, right? It's like we might need to... I think that one was an anomaly, because it depends when they wake up, right? See, that one woke up, then that one, then that one. Then they would have different oscillations. Yeah. Yeah, it depends when they wake up to kind of, if they're synced on their oscillations or not. Well, and the frequency. I think that's fine. Because I'm intentionally trying to like bunch them up together. Yeah, and then the more they move, the more they get disjointed, because different walk speeds and frequencies. Okay, let's do a little bit bigger. Okay, so what we'll do, this will be the value for the init on... we just need to change... We'll take this out of the... Well, you know what? For right now, I'm just going to leave it, because if we take out this stuff and put it in the idle init for the bat idle state, we could have the, all this stuff in one location, which would be nice, but we'd also have to take it out of the entity copy, because we're not providing the definition for it in the entity defs. And I don't want to take that out of there because I don't know if the bats are going to be spawned in idle in the demo. So I think I'm just going to leave it with these manual ones for now. And then if we decide we don't even need an idle state, then we can just kind of do this in the init for the walk state and take it out of the entity defs. So I think that's where I'm at with it. And we'll just copy from the zigzag time down. And we'll take out the walk speed. Okay. Okay. I think I'm happy with that. And I don't think there'll be 3 bats on screen at once in the demo. I think what I want to do is have a bat hole that they fly out of, and it's just a spawner, right? So like if you kill the bat, then another one will fly out and come for you again. I don't think we'll have multiple on screen at once. So it's nice that we have the ability to, in case the last dungeon we have like 2 bat holes or 3 bat holes. I don't exactly know, but nice. Cool. Yes. And then we need to also separate our enemy entities from our scene somehow, because our bat just rendered under the treasure chest, because the treasure chest is outside of the scene. I think it's outside of the map and it's in the scene. I think we need to do the same thing with our bats, because also right here, this part is at a top level tile layer, so it renders above us as we walk through it. And if the bat flies through there, it also renders on top of the bat, which is incorrect. So we need to see, and that's tough because it's like we need the bat to render on top of the player. I guess it would just be top level, just like this one. Even more so on top of the top level tile because it's above everything. Okay, so I think what I want to do is just remove our attack state, because we just don't have an attack state anymore. So we'll remove that, and then we'll do our git commit. So bat attack state, I believe you are gone. Let's just double check and make sure. All we're doing is rendering the entity, changing to a bat flee state, which we are doing from the walk state, and then whether or not adding a spitball. And then also the same duplicated distance to player function. So yeah, we're good deleting the attack state. And then we can also delete in our dependencies the attack state as well. Cool. So let's check out our git diff and see what we did. Okay, in our entities, we pull a defined zigzag. Now, I feel like we need to do an or nil here, because if we don't define a zigzag time, we can't pull the defined value, right? So I guess if we pull, I think if we were to spawn a gecko, it would crash there because it doesn't have a zigzag definition. So I think we want to modify this to be or nil on the zigzags because they're optional. Okay. I think that's okay. And then let's continue looking. Okay, so we added our zigzag values for our bats. We took out our attack state. Wow, that's a lot of code we got rid of there. We save our original walk speed so we can reset our walk speed. And We got rid of our displacement stuff and changed to an attack timer. In our update, yeah, we're doing some new vectorized zigzag logic, and we took out all of our old logic. And then, yeah, we're just doing our vectorized positional updates plus a sine wave offset. And then we fixed our damage flash by taking out our set color in our walk state render. Okay, so I think I just want to clean up some of the comments in the bat walk state there. We don't need this. I'll keep that. We don't need this. Okay. The comments could be cleaner on that. That's kind of gross, but not necessarily needed. I'm okay with leaving that comment. Okay. Just make sure it runs and then we'll commit and call it a night. We run. Sweet. And then they flee in different directions depending on where we were at when we got them. This is looking great. Cool. We will commit and we'll say we added vectorized movement for bats and oscillating offset. Probably should have said we removed the attack state also, but I did not. Anyways, we get pushed. I'm going to run our credits here for our credited supporters. Thanks for hanging. We'll be back tomorrow, and I think we might get started on the title screen tomorrow, or we might dive into some dungeon development. I haven't decided yet. But let me see if Hypnotic Games is programming. He's playing chess. Let's see. I always like to try to raid out to someone who's programming. Adagon Dev is almost always programming. Yes, we'll raid out to Adagon Dev and call it a night. I'll be back tomorrow and we'll figure out what we're gonna do. I hope everyone has a great night, and I'll catch y'all later. Thanks for watching.